Yeah, we're looking at the integration by parts, part two, and want to look at questions to buttress more, to buttress integration by parts. So let's look at the first question. We have S cube sin x. Okay, so the two of them is differentiable, and the two of them is you can integrate it. So we're going to follow the standard rule. So this will be our u. So u is what? S cube. And the v is equal to sin x dx. So my du now will be equal to x. That will be 3x2. The du will be 3x2. Yeah, 3x2. Okay, then integrate both sides of this equation. Then v equal to what? Minus cos x. So I'm using uv minus v integral of v du. So my u is what? uv, then minus integral. So that will be uv is what? Is minus x3 cos x, then minus integral of my v is what? Cos x. Okay, then with the minus here for v, put this onto the plus. Okay, then times 3x squared. Okay, don't forget this place. The u is 3x squared dx. So dx. Okay. Then what we can do now, we're going to have your integral, which we can call this one I, the equation. Okay, equal to minus x cubed cos x. Then the 3 here can go outside, so plus 3 integral of x squared cos x dx. Okay, we're going to repeat the integration again. So we're going to have I equal to minus x3 cos x, then plus 3 into brackets. Let's do this one again. U is what? U is x squared. The u is what? 2x. Okay. So then the v is equal to cos x. So v is what? Sin x. If we integrate sine, you have cos. So let's plug in that uv, that's x squared sin x. Okay. Then followed by minus integral of v sin x times the u. The u will be 2 x. 2 can come outside, then dx. So this is what we have. Again, we're going to integrate this one again. so we'll do that. Then we now have now, we can start opening. So I equal to minus x cubed cos x. Then open this one and plus 3x squared sin x. Then minus 6 integral of 3 times 2, that's minus 6 integral of x sin x dx. Okay, so then the next thing to do now is we can take this one again, this integral by part. This is a product, this is u, this is v. Okay, so u is x, so du is equal to what? Dx. And then your dv is your what? Sin x. So which means v is what? Integral of sine is minus cos. So begin to plug in uv. Okay, minus what? Minus integral of v. So integral of v du. So that will be x minus cos x. This one times this one. Then minus integral of v minus cos x. The minus here in this one become plus. That's cos x. Then the u is equal to dx. Okay, so this will give us what? This will give us, for this integral, we're going to have minus x cos x, and then plus integral of sine, that's integral of cos, that's sin x. So we can go back to where we started from. So I will now become minus s to the power 3 cos x plus 3x squared sin x minus 6 into brackets minus x cos x plus there's no space there. Let's do it here. So minus 6 into brackets minus 6 into bracket minus x cos x plus sin x. You close it. Then you can open the bracket. That will be minus s cubed cos x plus 3s squared sin x. Then this one times this one, that's plus, that's minus plus, then 6x cos x, 6x cos x, okay, and then minus 6 sin x plus c. So that's that we got for that question. It's a little bit long. That's what we got for that. Okay. Okay. We can check. I think there is a little here. UV. U is a s cube. Yeah. Times cos. Yeah, it's correct. Yeah, it's correct. Yeah, it's correct. Yeah, it's correct. We have integral of log x base e all square dx. Okay, so what we're going to do here is going to be, I'm going to make it log x base e times 1 times dx. This one can go to square times dx times 1 times dx. We just want to split into two parts. Okay, you cannot integrate this. Okay, you can't integrate, you can only differentiate it. So use what? Differentiable. Log is differentiable functions. So that's what u is equal to log this. We're going to call it u. Everything there we're going to call it u. And we're going to call this one 1 times dx. That's the v is equal to what? Dx. So x is what? V is what? Is x. Okay. So if we differentiate your du, your du will be equal to 2, okay, log the function, okay, and then times, no, it's like this one is like a v squared, so it should be 2v, okay, times the derivative of the v, which is equal to what? 1 over what? 1 over x. Okay, the v is log x base e, okay, and the derivative of that is 1 over x. The derivative of this is 1 over the function itself. So that gives 2 over x log x base e. Okay, let's do the uv. My uv will be that will be x. My question, I call it I. Okay, that's I equal to uv x log is your uv. Then minus integral of v. My v is x du. Du is what? 2 over x log of this. Then dx. Okay, dx. So this one will go. Then I'll have I equal to x log to base e, this one square. And that will be, these two can go outside, that will be 2 integral of log x to base e dx. Okay, so I'm going to repeat the integration again, and that will be equal to I'm going to repeat the integration again. This one, repeat again. So your u is what? Log x base e. So then your v Your v is what? Dx. So v is what? X. Okay, and then your du here is 1 over x dx. Your du there is 1 over x dx. If you differentiate logarithm to base e, it's always the derivative of this function over the function itself. Okay, so we have that. V is what? My v is is x times du. Du is 1 over what? 1 over x dx. Okay, so that gives me x log this 2, the minus 2 into brackets x log this x log this. Then this will cancel out, this will cancel out. Then I have integral of what? Integral of dx. Integral of dx. This one and this one will cancel out. So my answer will be equal to x log x this square minus 2 into bracket x log x is e minus x. Okay, so that's that on that question. And then don't forget to put C. Forget to put your C plus C. So that's that on that question. Go to question 3. Yeah, for question 3, we do have integral of x5, x to the power 5, log 3x base e dx. So if you check very well, this is differentiable. We know that. This is also differentiable. This is integrable. You can integrate this, but you can't integrate this. You can't integrate log. So what you do is that you have to call this one. You can only differentiate this. So this will be u. This log will be u. So log of this to this. And then the u will be equal to what? The u will be equal to derivative of this function here, 3, over the function itself, over 3x. That's 1 over x dx. Okay? Then again, my dv, it will be equal to x5 dx. So v is equal to what? X6. You know, so integrate just plus 1 for the power, and then over the, whatever you get, plus 1 over the power again, plus 6. So that's that. Then let's see the formula. The question, can we call it I? I equal to uv. My u is what? That will be x6 over 6 log this e uv, then minus integral of my v, x6 over 6 times the u. My du is what? 1 over what? 1 over x dx. Okay? And this will be equal to s6 over 6 log 3x base e, then minus integral of what? You can take the 6 out, okay, and that will be x5 dx. One more point, one more step. Finally, we have this over 6 log 3x minus 1 over 6 times integral of this is what? X6 over 6 plus 6. So that will be equal to, this will be equal to 1 over 36 minus 1 over 36, 6 times 6, x6 plus 6. Then write this one again. So that's that. Write that one again. So that's the answer to that. That's the answer to that. Okay. Then we'll go to question 4. Yeah, we'll go to question 4 and see what we can do there. Go to question 4. Integral of x arcsine inverse of sine. So if you check very well, we cannot integrate this. We can differentiate it. So we call that one u. Okay? But it's more better. You can't differentiate it. So it definitely be u. So u equals what? Arcsine what? Arcsine this. So and the du will be equal to this will take us that the u will be equal to 1 over square root 1 minus x squared dx. And your dv is equal to x. So v is equal to what? X squared over 2. Okay? So if you differentiate inverse of sine, is what we're going to give you. So let's begin this plugin. So what we do now is for us to have uv, which is x squared over 2, I equal to. The question is equal to I equal to arc sine x, that's uv, that's your uv, then minus integral over v x cubed over 2 times the u, 1 over this minus x squared dx. So what we do now, we're going to, for this one here, we're going to do use trigonometry substitutions. This is 1 minus x squared. Okay, we're going to do trigonometry substitution. But before that, let's just take that 2 out. Let's take this 2 out. This 2 here minus half into bracket x cubed over square root of what? Minus x squared. And yes, so what I want to do now, I want to solve this one. Okay, so use what? Use for this integral, use trig substitution. Use trig substitutions. That's the method I want to use here. Okay, and one of my videos I've already shed light. I've shed light on these trigonometry substitutions. So that this for this one, that will be x equal to what? Sine theta. This will be sine theta. Okay. So with that now, we can now have now that integral will be equal to this one, s squared will be equal to what? Sine squared theta all over this one. That's 1 minus what? Sine squared theta. And don't forget that sine squared theta is equal to 1 minus cos squared theta. Okay? And what am I saying? What I mean is this. What we mean is this. Cos squared theta is equal to 1 minus sine squared theta. Look at what we have here. 1 minus sine squared theta is equal to cos squared theta. And there is square root on it. Okay? So, and if your x is sine theta, then the x is equal to what? Cos theta d theta. If you differentiate this one, the s d theta will give you cos theta. Okay? If it's not clear, if you have x equal to sine theta, you can get your dx respect to theta. And that will be equal to what? Cos theta. And then you can cos multiply by what? By theta. So you have the s equal to what? Cos theta d theta. So don't forget what you have here. This is there is a dx here. Okay, there's dx there. So integral sine theta, sine squared theta, all over cos theta. Okay, I've shown you this one. Okay, use it here. This one is cos square theta, the square root, that's cos theta. Then your ds is what? Your ds is cos theta d theta. So this one and this one will cancel. So you have integral of what? Sine square theta d theta. Okay, sine square theta d theta. That's what we have there. Okay, sine square theta d theta. So we want to turn that one to double angle, but we cannot integrate this. We have to turn to double angle. Don't forget that cos 2 theta is equal to 1 minus 2 sine square what? 2 sine square theta. Then you can make this one the subject. Then you have sine theta equal to what? Half into bracket 1 minus cos 2 theta. Okay? Cos 2 theta. So this is sine square theta. So I will go there now. I will now put it there. Then I will now have. Don't forget, we'll come back here. That's I'll just take this, just extract this one out. Okay. So so this is what we have now. We now have for sine square theta. Now we have half into bracket sine half into bracket half into bracket 1 minus cos 2 theta. So which will be equal to half outside, then integral of this. This is the theta. So that will be theta minus integral of cos sine 2 theta. Then divide by the half here, the constant attached to the variable. So over what? Over half. Okay, so now what we have there. But if you check the question, if you check this, what we have is the function of x. Theta is not in the variable, so we have to substitute back. Okay, and then we'll start from here. If x is sine theta, that means theta is what? Arc sine what? Arc sine x. That one is that one. Okay, let's also work on sine 2 theta also. Sine 2 theta is equal to 2 sine theta cos theta. We know the value of sine theta. Okay, so this will be equal to 2 sine theta. Cos theta will be equal to what? Square root of what? 1 minus what? 1 minus sine squared theta. Okay, we just try to turn everything here to sine, in form of sine. Okay, then we can substitute now for sine 2 theta, which will be equal to sine theta is what? Is x. So that will be 2x. And this will be equal to what? Square root of what? 1 minus x squared. Okay, so what we just need to do now is just to go back there and substitute. But before we do that, we have to come back here and express it in the form of x. So that will be half into brackets. My theta is what? Half sine x. Okay, minus half. Sine 2 theta is what? 2x square root 1 minus what? S squared. Okay, so 2 we cancel here. 2 we cancel there, don't forget that. So I think we have finished now. We just want to just go back here and do the final substitutions. Okay, we have an expression. Take the expression. We have half arc sine x minus x root 1 minus x squared. So that's what we have there. That's what we have there. Oh. Sorry, please. Yeah, half here, yes. Then here, half is here, half is here. That half goes in. So that will be half that. Then here also, two halves, 2 here has already cancelled out. But half is coming in. So that's half over 2 here. Okay, over 2 there. So that's good. Okay, your half here. Okay, and here also, each of them is having half times this. That's this. Then half times x. That's s over 2. So final answer will just be equal to what? It will be equal to s squared over 2 arc sine this minus 1 over 4 arc sine x, and then plus x over 4 1 minus x squared plus c. So that's that on that question. It's very tactful. Take time. It's very simple. Just for you to be able to play with identity, and yeah, I'm able to use your trick substitutions. And that's what we have done in this question. So we have one more questions. Okay, I'll try to do that in the next question. Okay, please, if you are new on the channel, please hit that notification bell so that as we upload, you get notified. Thank you for doing that.